in this video, we're going to go over a really important concept, which we need to do before we decide on what the transformations are in a function. Let me explain what that means. So let's just say, for example, I have a function that's y equals f of x, and I'm transforming it, and I transform it to y equals negative 2 f of 3x plus 12 minus 1. So if you were to sort of determine what the transformations are, you might think, oh, well, that negative, that means a reflection over the x-axis. That 2 means it's a vertical stretch or a stretch in the y direction by a factor of 2. There's that 3x, so that's on the inside of f, so therefore it's a horizontal stretch by a factor of 1/3. And then there's the plus 12, which means that it's translated to the left by 12 units, and then the negative 1, which means it's down by 1 unit. And if you think those are the transformations, you would actually be incorrect. What you would actually do in order to be correct is to actually factor the inside of the f. So it would go like this. So it's negative 2 f of 3, and then it's x plus 4 minus 1, because 3 times x is 3x, and 3 times 4 is 12. In order to explain why we have to factor, I'm going to answer this question by sort of an analogy. So here's the analogy. So imagine I'm going to write down a quadratic function, and the quadratic function is the following. So it's 2x plus 3 squared minus 19. And this is equivalent to 2x squared plus 12x minus 1. And you can trust me that the expansion of this is equal to this. But if you want to go for it, try it by yourself. Expand x plus 3 squared, multiply by 2, and then subtract 19. And this is exactly what you will get. So let's say, for example, I'm basically sort of doing a transformation. So the most basic function is y equals x squared. So here's y equals x squared, and say I transform this function to y equals 2x squared plus 12x minus 1. So in other words, this one to the right. Well, the thing is, if I were to determine what the transformations are, it would be really hard to determine, because the one thing that we can tell right away is that there's a vertical stretch by 2, but then the 12x minus 1 really don't tell us much more information. Because remember, the negative 1 in this standard form of the quadratic function is simply the y-intercept. It doesn't tell you whether it's moved up or down or left or right. So this really doesn't give you much information in terms of the transformations, what we've done in terms of reflecting, stretching, or translating. We definitely know the stretch, but that's about it. Now, what if I were to write y equals x squared, and I transform that function to y equals 2x plus 3 squared minus 19? Well, if you observe over here, y equals x squared, the vertex there is 0, 0. The 2 over here tells us that it's been vertically stretched by in the y direction by a factor of 2. We know that the vertex is negative 3, negative 19, or in other words, it has been translated to the left 3 because of that plus, and then down 19 units. So this form, what I'm trying to get at is that this form gives us much more valuable information than the other one. In other words, this form is factored, whereas this other one over here doesn't really give us much information. So here's little information, here's little info, and here is a lot of info. In fact, it's exact info, a lot of info about the transformations. So that's why it's crucial that you factor or sort of get into this form when you're transforming. So let's go back here, and that's why this 3x plus 12 needs to be factored into this form. And now we have so much more information, and we can tell decisively what the transformations are. So for example, this negative tells us it's a reflection over the x-axis, remember it affects the y's, so it's the x-axis, we have a stretch in the y direction. We have a stretch in the y direction. And I should write by a factor of, but I don't have space here, but it's by a factor of 2 because of that. Then we have a stretch in the x direction by, and if this is 3, it should be 1/3. Remember, it's always the reciprocal. And finally, this is the translations. So we can see translate, since this is +4, this is 4 units left and 1 unit down. So again, the key thing to remember is that when you're given functional notation and you're trying to determine what the transformations are, make sure you factor first. Once you've factored, then you can determine what the transformations are. All right, I'll see you in the next video.